Welcome to Shiwam's classes. In today's lecture, we are going to discuss problem number 5, 6 and 7 of chapter 3, exercise 3.3. In last lectures, we had discussed problem 1 to 4 and now we'll start today with problem number 5. So when you look at problem number 5, it starts with finding out the value of sine 75 degree and tan 15 degree. So in such problems, what we need to do is we need to reduce such degrees or such angles to a manageable degrees which we know already. So if you remember from your last classes like 10th, we had calculated values of 0 degree, 30 degree, 40 degree, 60 degree and 90 degree of various trigonometric functions sine, cos, tan, right? So you know the value of sine is sine 0 degree is 0, sine 30 degrees 1 by 2, sine 45 degrees 1 by root 2 and so on and so forth. So if you know values of sine, cos and tan, you know, right, you can actually get the values of cosec, cosec theta, sec theta and tan theta because and cot theta because they are reciprocals of sine, cos and tan, right? So you can say cosec theta is nothing but 1 upon sine theta, sec theta is nothing but 1 upon cos theta and cot theta is nothing but 1 upon tan theta. So for each values of 0, 30 or 45 degree we can get values of these as well. So you just have to remember these values and we will work with these values now. Okay, so now coming to the first problem, here we have sine 75 degree. We don't know the value of sine 75 degree, but we do know the value of 45 and 30 degree. So what we'll do is we will write 75 degree as 45 degree plus 30 degree. All right. And now when you look at this expression, you know that we have also learned a new formula which is sine a plus b. Sine a plus b is sine a into cos b plus cos a into sine b, right? So if here this 45 degree becomes a and 30 degree becomes b, then what will this expression become? This expression will become sine 45 degree into cos 30 degree plus cos 45 degree into sine 30 degree. Yeah, you can look at this formula. Now we know the value of sine 45 degrees. Sine 45 degree is nothing but 1 upon root 2. We also know the value of cos 30 degree, which is nothing but root 3 by 2. We know the value of cos 45 degree, which is again 1 upon root 2, and sine 30 degree is nothing but 1 by 2. Now you can see the expression here. In the denominator we have 2 square root of 2. So we can take 2 square root 2 as LCM, and what will happen to the numerator is this will become root 3 and this will become plus 1. So this is what the answer would be, root 3 plus 1 divided by 2 root 2. That will be your answer. Let's go to the second part of it, which is tan 15 degree. We'll calculate the value of tan 15 degree. So again, we do not know the value of tan 15 degree, but we do know the value of 45 and 30 degree. So can we write tan 15 degree to tan of 45 degree minus 30 degree? And we also know something, that tan of a minus b is tan of a minus tan of b divided by 1 minus tan a into tan b. This we have already understood in the chapter. So now if you look at this value, if this becomes my a, this becomes my b, the expression becomes tan a minus b, and what I can write over here is tan 45 degree minus tan 30 degree divided by 1 minus tan 45 degree into tan 30 degree. Alright, because the tan 45 degree is tan A, tan 30 degree is tan B. So this is what the expression would become. We also know the value of tan 45 degree, which is 1. We know the value of tan 30 degree, which is 1 upon root 3. We know the value of tan 45 degree, again it's 1 into 1 upon root 3. So now we can take an LCM of root 3 here, right? When we take LCM of root 3, then this will become root 3 and then this will become minus 1, right? And again in the denominator we take square root 3 as LCM, then this will become root 3 minus 1 because this will be multiplied here minus. Okay, so here it is minus and then here it is plus, right? This is tan A minus tan B and this is plus, right? So this is what I shouldn't be making a mistake here. So this is root 3 plus 1. Alright, now root 3 is gone. Now we are left with root 3 minus 1 divided by root 3 plus 1. You have arrived at some value, but generally when we have some prime number, when we have some irrational number like this in the denominator, we try to reduce it to a better value. So what we do, we generally multiply it by a quantity which can make it more like a rational number, right? So what we do is, in such cases, we multiply it by root 3 minus 1. Whatever be the sign of this, we multiply it by a quantity which is opposite in the sign. So if it had been in root 3 minus 1 in denominator, I would have multiplied with root 3 plus 1 in the numerator and denominator both. So this quantity is nothing but 1, right? If I just strike it out, it will be 1, right? So this entire expression will not change, right? But it will get simplified, right? What will happen is, this is again root 3 minus 1, this is also root 3 minus 1, so this will become root 3 minus 1 whole square, while a denominator will become root 3 plus 1 and root 3 minus 1. This is nothing but, if you look at the expression a plus b into a minus b, and which is nothing but a square minus b square. So in this case, what will happen, this will become root 3 square minus 1 square. So now coming to this part, if you can expand it, it's a minus b whole square. So this will be root 3 whole square plus 1 square minus 2 times of root 3, and which will be divided by root 3 square, which is 3, and then there will be minus 1 over here. Now root 3 whole square is 3, then 1 square is 1, and minus 2 root 3 and divided by 2. Now this will become 4 minus 2 root 3 divided by 2. You can take 2 common and then it will become 2 minus root 3 divided by 2. 2 will get cancelled out and then you will be reduced with 2 minus root 3, and which will be your answer. So you can look at here, this is more manageable number than this, right? If we had stopped over here. So that is why whenever we are dealing with an irrational number, we generally try to reduce the denominator by multiplying it by a factor such that it becomes a rational number. This is something which we do generally. Alright, so let's move on to the next problem. The next problem talks about some quantity multiplied by some quantity, and we have to prove that LHS equals to RHS. Alright, so when you look at this problem closely, what you can see, that this quantity pi by 4 minus x is also over here, pi by 4 minus x, and this quantity, if you call it like this is also over here, pi by 4 minus y. So if let's say we assume pi by 4 minus x is a and pi by 4 minus y is b, then the whole expression of LHS will become what? LHS will become cos a into cos b minus sin a into sin b, and we know that this is a formula of cos a plus b, so we can just write cos a plus b. Now put back the values again. So what will happen here is, we can put pi by 4 minus x plus pi by 4 minus y. Alright, so why did we do that? So when you look at this expression, you could have understood that this is coming to a formula, and that is why you were just trying to minimize the error by just calling it a and b. So we called it a and b, and then this formula appeared to be very familiar, and that's why we came to this step. Now when you came to this step, now you can see that this and this will get added. So pi by 4 plus pi by 4, then you add both of them, it will become pi by 2, right? Or you just write pi by 4 into 2, this is 2 times this, and then minus x minus y. When this will get cancelled out, then this will be cos of pi by 2 and minus, I'll take common, and then this will become x plus y. And if cos of pi by 2, so we know that cos of pi by 2 minus theta is nothing but sine theta, right? This is also we know, because first of all this is in first quadrant, this pi by 2 minus theta, this pi by 2 minus theta is in first quadrant, and cos is having an odd multiple of pi by 2, so cos will become sine. So then this expression will become sine of x plus y, which is nothing but what we have to do, we have to matches. Alright, so let's move on to the next problem. So next problem is talking about tan pi by 4 plus x, tan pi by 4 minus x, and we have to prove it that it is equal to 1 plus tan x divided by 1 minus tan x whole square. So again, if you are looking closely, you can see that tan pi by 4, if we call it a and call it x as b, then this is nothing but tan a plus b, and the denominator is tan a minus b. So we know the formula of tan a plus b and tan a minus b, right? So we'll again write the formula of tan a minus b here, because we have already written in previous example tan a plus b's formula. So this will be tan a minus tan b divided by 1 plus tan a into tan b. Alright, so let's put that down. First let's write tan pi by 4 plus x divided by tan pi by 4 minus x. Now let's write it as tan a plus tan b. So tan a is tan pi by 4 plus tan b is tan x, and then divided by 1 minus tan a, this is nothing but tan pi by 4, into tan b, which is nothing but tan x, and then again divided by, and then it is tan a minus b, so we'll have to write tan pi by 4 minus tan of x divided by 1 plus tan pi by 4 into tan x. Alright, now the numerator, so we know the value of tan pi by 4. So tan pi by 4 is what? Pi by 4 is nothing but 180 degree by 4, which is 45 degree. So we know the value of tan 45 degree, which is 1. So we'll put 1 plus tan x divided by 1 minus tan x. And then here it will again be 1 minus tan x divided by 1 plus tan x. So when you just simplify it, you can put the numerator as denominator, denominator as numerator. So this will become 1 plus tan x divided by 1 minus tan x, and then this part will go to the top, so it will become 1 plus tan x, and this will come down, which will be 1 minus tan x. So when you look at this expression, this is 1 plus tan x, 1 plus tan x, so this is nothing but 1 plus tan x whole square, and then denominator is 1 minus tan x whole square. So when you reduce it further, this will become 1 plus tan x divided by 1 minus tan x whole square. This is what we have to prove on the right hand side. RHS proved. Alright, so these are the three basic questions we wanted to discuss. If you have any questions, please ask me in the comment section below, and thank you for watching.